Yeah. You guys need to re-watch these because they're so nicely done.
I'm just not going to watch them. When I have to revise them for the exam because everything's gone out of my head, I'll re-watch them all.
And then you'll get some really nice
who's got an equation for kinetic energy for us?
K equals S2 plus 6.
Well, you're going to beat me.
That's wrong. That was a guess.
EK equals 1/2 mv squared.
Who's got gravitational potential?
I've got...
oh gosh, just a lot. Triangle EP grab equals mg triangle H. Just like, I was thinking of elastic.
Okay, types of energy we need to know this year. The only two that we have to be able to calculate are kinetic and gravitational potential energy. Kinetic energy is, we think about it as being the energy of motion. So when a body is in motion, when something is moving, its energy depends on its mass and on how fast it's moving. Mass is measured in. Velocity is measured in. Kinetic energy is measured in.
Goodness. Oh dear. Oh my. Oh dearie me.
And then coming across to gravitational potential energy. Gravitational potential energy.
Oh no.
When we talk about all these potential energies, what we're thinking about potential, like what's the potential it would have if we let it go and it could fall? If we released all that energy as kinetic energy, how much would it have? That's what we mean by potential energy. So gravitational potential, we lift something up in a gravitational field. The higher we lift it up, the more gravitational potential energy it's got, so that when we let it go, the faster it goes. Like, the higher it is.
I'm doing really badly. I'm doing so bad. I'm really sorry guys, whoever rewatches this one, it's not going to be too good.
How much is acceleration due to gravity this year?
10
10.
meters per second per second.
What happens if you did like whatever it is, 9.91? Would they range? Was it 9.91 that you said it was in year 13?
Yeah, 9.81.
9.81.
Yeah. And we've got two different units, remember, for that gravity. We've got 10 meters per second squared or 10 newtons per kilogram. Like newtons per kilogram, how much force is there for each kilogram of mass, versus meters per second squared, like how fast does that mass accelerate when we let it go. Delta H means what? The change in height in the gravitational field. So not the height, but how much the height has changed by. What's that measured in?
Various different
Meters.
Yeah.
And gravitational potential energy is measured in
That's incorrect.
joules.
Oh, again.
Elastic potential energy. When we think about elastic potential energy, we think about the energy that we store in something as we stretch it or as we compress it. So we know that we can store energy like in a catapult, like pulling back on the catapult, then letting it go. We don't have to calculate elastic potential energy until next year. Heat. How do we create heat energy? What creates heat energy?
Friction.
Friction. Right? If you're not sure, try rubbing your hand on the table back and forth as fast as you can. It's hot, right? So kinetic energy is transformed into heat energy by friction. Chemical potential energy, we're thinking about like energy stored in chemical bonds. So like when we burn petrol, in our car's engine, we're releasing the energy that's stored in the bonds in the petrol by reacting them with oxygen in the air to release that chemical potential energy, and we turn it into heat energy as well as kinetic energy.
Sorry.
Light energy and sound energy. Like light energy is the energy carried by the wiggling electromagnetic field as light travels through it, and sound energy is carried by wiggling particles in the air or in another material as they wiggle back and forth as the sound travels through. Interestingly, they say that if our eyes were as sensitive to energy as our ears were, we'd be able to see a candle burning on the moon.
Ooh.
So, like our ears, our sensitivity to sound energy is just enormous compared to our sensitivity to light energy, which is not that great. Do you want to redo the falling object thing?
Oh, why?
Do you want to have another go?
Okay. Like with following it?
Yeah.
Okay.
Maybe.
Maybe not a rock.
Okay. Ready?
Yeah.
So when something falls, it goes like...
That was really good. No, I think that was nice.